When children around the world begin taking their first geography lessons, typically the singular first item on the agenda is for them to memorize the names and locations of all the continents. Every country's educational standards require their children to learn this topic, making the names and locations of continents one of the few concepts that we can truly say is globally recognized. And, well, why shouldn't it be? We all live on the same planet, so of course each country and culture should agree with each other about the names and locations of the Earth's continents. This is anything but true. Strangely enough, it seems like despite being a universally recognized concept, there isn't really a universally understood definition of what a continent actually is. I grew up and went to school in the United States, and when I first learned geography, I was informed that there were 7 continents in the world: North America, South America, Europe, Asia, Australia, Africa, and Antarctica. But had I been born and educated in most of Latin America or Southern Europe, that whole idea of North and South America being distinct continents would have been completely foreign to me. Rather, students in these countries learn that they are one combined large continent. America. Just America. After all, the northern and southern parts of America are connected to each other, so why should they be considered separate continents? Except, wait a minute, Europe and Asia are connected to each other by land, even more so than North and South America. So maybe we should be like the school systems of Eastern Europe, and teach kids that Europe and Asia are in fact not distinct continents at all, but rather mere subsections of the larger Eurasian continent. Except, again, wait, Africa is connected to Asia by land as well. So the 3 continents logically should be combined to form one massive continent, Afro-Eurasia. I mean, that's what makes the most sense, right? I bring this up to show how the idea of continents themselves are a cultural construct, a convenient but arbitrary category created by human beings to help us to divide, categorize, and understand our complex world. Whether this takes the form of connected but cartographically distinct landmasses, like in the case of the Americas or Africa and Asia, or like in the case of Europe and Asia, is literally just an arbitrary separation drawn at an arbitrary mountain range based on perceived cultural distinctions on each side of the mountains. The idea of what is and isn't a distinct continent is not some objectively agreed upon notion, but rather a matter of perspective. But what about islands? Islands are, by definition, not connected to any larger landmass. So are they just not a part of any continent? Well, the default response is for an island to be considered a part of whichever continent it's geographically closer to. But sometimes it can be a bit more complicated even than that. Which brings us to Madagascar. Located in the western portion of the Indian Ocean, around 300 miles away from the African mainland, Madagascar has always had an unusual relationship with its continental identification. While the island is almost universally considered to be a part of the African continent, given its geographic proximity, its relative isolation has consistently given Madagascar the strange status of being a distinct member of the continent. For example, the now defunct organization that promoted unity among French-speaking African nations, the African and Malagasy Union, plainly and ironically drew a distinction between Madagascar and the rest of Africa within its own nomenclature. And the more you learn about Madagascar, the more you can understand this impulse to distinguish the island not only from mainland Africa, but really from any other part of the world. While it's obviously difficult to back up such a subjective statement with quantitative data, Madagascar might be the single most interesting place in the entire world. Whether it's the flora, fauna, climate, human history, or material culture, Madagascar consistently subverts expectation and defies categorization. The country is truly a gem, packing an entire continent's worth of diversity in any conceivable metric into a single island. It's no surprise, then, that Madagascar has earned a nickname that truly showcases its status as the most unique place on Earth: the 8th continent. Hello everyone, and welcome to the first episode of our 4th season. In our new series, we will take a leap into the history of Imerina, the fascinating kingdom that dominated and eventually united early modern Madagascar. We will learn about the governmental, economic, and social institutions that govern life in the kingdom, the achievements, triumphs, and setbacks of the kingdom and its people, and understand the story of how this miraculous society first emerged, flourished, and eventually collapsed. But before we can truly launch into the history of the Marina people and their kingdom, we must first understand the island that they called home. Season 4, Episode 1. Madagascar, the 8th continent. If your understanding of the idea of a continent is based solely on its physical size, then Madagascar's nickname might not make a lot of sense. Don't get me wrong, Madagascar is a pretty big country with almost 600,000 square kilometers in landmass. For reference, that's about 3 times the size of the island of Great Britain, and larger than all but 2 countries in Europe. But compared to the regions that are generally accepted as continents, the so-called 8th continent doesn't hold up in size. However, the honorific nickname of the 8th continent is not intended to reflect Madagascar's physical size, but rather its unusually potent natural diversity. Whether in terms of climate, plants, or animals, describing the island of Madagascar really does make you feel like you're describing an entire continent. Take, for example, the island's climate zones. Most islands around the world, even the larger ones, are typically filled by 1 or maybe 2 climate zones. Take the world's largest island, Greenland. With an enormous area that itself triples Madagascar in size, Greenland hosts a total of 2 climate zones according to the Köppen Climate Index: tundra on its coastlines and ice caps in the interior. One of the few other islands that exceeds Madagascar in size, the Indonesian island of Borneo, is even more uniform, with exactly 1 climate, moist equatorial, defining the entirety of the island. Madagascar, on the other hand, features 10 distinct climate zones. Now, it would be excessive to go into detail about all 10, so let's discuss some of the broader regional climate archetypes found throughout the island of Madagascar. Of course, following along with geographical descriptions without a visual aid can be a little bit tricky, so if you want some visual aids and maps for this segment, you can find the appropriate images on our podcast blog, historyofafricapodcast.blogspot.com. If your mental image of Madagascar consists of a thick, humid rainforest, then you'll probably have an easy time picturing the lowland forest region of Madagascar. Stretching in a thin band along the island's eastern coast, the lowland forest is the most iconic region of the island. The region is defined by how well it is serviced by the Indian Ocean's monsoon winds. The forest is incredibly humid, with average annual humidity exceeding 80% in the region, as well as featuring high rainfall, with a typical year producing over 130 inches, or 333 centimeters, of precipitation. The East Coast soaking climate is, of course, amazing for plant life and biodiversity. The lowland forests are one of the most biologically unique regions on Earth, with more than 80% of the region's inhabiting flora and fauna species being fully unique to the island. So, if you're in the Malagasy Eastern Forest and spot 10 different plants and animals, approximately 8 of them would be species that you couldn't find anywhere else on the planet. Running along the center of Madagascar, as if it were the island's spine, is the Malagasy Highlands. Constructed by a series of closely packed mountain ranges and plateaus, the highlands of Madagascar stretch from the island's far north to the far south, essentially forming an enormous block in the inland center of the island. This block is only interrupted at one point, with a thin valley crossing through the northern section of the highlands. As a result, roughly a fifth of the highlands, which are north of this dividing valley, are designated as the Northern Highlands, while the remaining portion are the Central Highlands. Unlike the Eastern Forest, which stays wet year-round, the highlands experience radical seasonal changes. During the wet season, the highlands will receive ample rainfall, usually around 10 to 14 inches each month. Make sure you don't use that water up though, since for the coming 4-month dry season, each month will produce about a fifth of an inch of water. The exact historical climate of this region is, surprisingly, a matter of bitter controversy. In general, the Malagasy Highlands of today are a flat, largely treeless region, dominated by sprawling grasslands and agrarian fields. This was not always the case, though. You see, pollen and subfossil records from the region indicate that the highlands were once a considerably forested region. Sure, it wasn't anything as dense as the eastern coastal forest, but there was strong evidence that the region once hosted a healthy tree cover, something you wouldn't expect by looking at the temperate, treeless grasslands of today. This is where the contention comes in. Similar to the famous environmentalist narratives of Rapa Nui, or Eastern Island, there is a pervasive narrative that the destruction of the highland forest was an entirely anthropogenic affair. According to this narrative, the local population, through the widespread use of unsustainable methods of slash and burn agriculture, gradually ensured the death of the highlands forest. This narrative has been disputed, with many historians either attacking the theory as lacking evidence or too heavily based on assumptions while ignoring other likely factors in forest decline. But is the theory true? We'll certainly get into that in the future. Regardless of how the region came to its present state, the seasonal grassland climate of the highlands, combined with the region's lack of trees, high monsoon winds, and highly erodible soil, has resulted in some interesting, if not necessarily positive, landscape phenomenon, the most famous of which is the lavaca. Lavacas are a type of gully formed by a complex process of soil erosion, which essentially causes the land on a hill face to completely cave in on itself, forming what can resemble essentially a crater or canyon in the middle of a hillside. While they can and have occurred in other parts of the world, this phenomenon is so unusually present in highlands Madagascar that its internationally used nomenclature is itself a product of the Malagasy word for hole. The central highlands of Madagascar, though, are perhaps the most famous region of Madagascar in terms of its human history, and will be the central geographic focus for the majority of events in our current season. So if you ever catch yourself wondering where exactly we are on the island in any part of the season, the answer is most likely the Central Highlands. Much like the Ethiopian highlands that we examined 2 seasons ago, the Malagasy highlands also create a rain shadow effect over half of the island. As the monsoon winds approach Madagascar from the northeast, the highlands absorb or reflect a majority of the moist clouds. As a result, the western portion of Madagascar is significantly drier than the east. The rain shadow effect is least pronounced, though, in the northwest, which still receives significant seasonal rainfall, though to a lesser degree than the eastern rainforest. Despite this ample rainfall, though, the northwest of Madagascar is, and likely always has been, the island's least populated ecoregion. Northwestern soil is generally the least productive agrarian soil in the country due to its high sand and iron oxide content, which gives the soil a unique orange hue. In addition to making agriculture in the region less productive, this infertile soil has enabled the development of a unique ecoregion in the northwestern region of Madagascar. Known as a dry broadleaf forest, western Madagascar hosts one of the only 2 examples of this climate on the African continent. And, funnily enough, the only other African dry broadleaf forest is also located on an island nation, Cape Verde. Regardless, like everything else in Madagascar, the dry forest of the west is incredibly unique. Due to its relatively dry climate and low fertility soil, smaller undergrowth struggles to grow in the northwest, though trees thrive due to the lack of competition for nutrients and higher water storage capacity. As a result, the southwestern landscape resembles essentially a forest with no floor, trees on barren sand. On the coastal stretches, though, the northwestern dry forest subsides into a more conventional mangrove swamp. The driest region of Madagascar is located in the southwest. Like the northwestern dry forest, the southwest of Madagascar is marked by poor quality iron-heavy soil. However, while the rain shadow produced by the Central Highlands slightly reduces the rainfall to the northwest, it heavily deprives the southwest of the monsoon winds, giving the region a markedly dry climate compared to the rest of the island. Weather in the island's southwest is best described as bipolar. Each year consists of a 3-month-long wet season of heavy rainfall, followed by a 9-month stretch with 0 precipitation. This unusual pattern of rainfall, coupled with the poor quality iron-rich soil, has created a biome that is, in and of itself, entirely unique to Madagascar. The spiny forest, as it is called, is named after the ubiquity of bristled shrub plants in the region. The undergrowth of the spiny forest is dominated by prickly succulent plants, evolved to survive and thrive for long periods without water. Meanwhile, the relative lack of competition for groundwater and nutrients allows species of baobab trees, entirely unique to this ecosphere, to thrive. And, in case you are wondering, These spiny forests constitute the primary habitat of Madagascar's most famous animal inhabitant, the ring-tailed lemur. So if you were under the impression from movies and television that ringtails live in moist rainforests, think again. Most of them live in semi-arid spiny forests of the southwest. Which brings us to perhaps the most famous element of Madagascar, its absurdly interesting flora and fauna. The island's long history of geographic isolation has permitted the island to become an ecological anomaly. As mentioned earlier, around 4/5 of terrestrial plants and animals that live on the island cannot be found anywhere else on Earth. And that's not even to mention the many endemic aquatic species that can be found in the sprawling coral reefs located off of the Malagasy coast. It is obviously an impossible task to get into the sheer volume of unique organisms that call the island home. Rather, in terms of understanding Madagascar's natural history, it is more important to be aware of a guiding principle of evolutionary biology that has guided the island's unique zoological and herbological development, known as insular evolution. According to this principle, populations of organisms that live in geographic isolation will undergo unusual hereditary trends. This is visible in really any isolated population, but is especially noticeable in islands, the ultimate isolated environment. Due to a lack of a pre-existing large terrestrial species on the island, the traits typically selected for in a species might be dramatically different. Take, for example, one of Madagascar's most prominent unique families of animals, the lemurs. The lemur's closest living evolutionary relatives are the lorises of Southeast Asia and bush babies from mainland Africa. Lorises and bush babies, in order to stay safe from larger predators, have remained small and nocturnal, with the largest of them reaching a little over a foot in length. Lemurs, on the other hand, faced less immediate danger from large predators, and thus evolved to grow larger and began living diurnally. Of course, though, the niche of large terrestrial predators did not stay empty. A species closely related to modern-day mongoose arrived on the island, and, like the lemurs, similarly evolved to become larger. Their modern descendants, known as fusa, are the largest terrestrial mammalian predators on the island, growing around 6 times the size of their mongoose cousins. While these species highlight the process of how insular evolution can lead to gigantism quite well, now extinct species illustrate it even better. One enormous extinct species of lemur, Archaeoindris, grew to the size of a silverback gorilla. An extinct tortoise on the island towered to over 4 feet, more than a meter in shell length. But by far the most impressive of the Malagasy megafauna were the Aepyornithidae, better known as elephant birds. These appropriately named flightless birds stood at a gargantuan 10 feet, or 3 meters tall, and weighed a staggering 4/5 of a ton, or 725 kilos, winning them the title of being the heaviest bird to ever live. So basically imagine an emu, except twice as tall and 14 times as heavy. All of the aforementioned flora and fauna, which sounds straight out of the Ice Age, in fact survived until relatively recently, with their extinctions being variably dated from the 500s BC until as close to today as the 1300s AD. The exact causes of their extinction is a matter of intense ongoing debate, potentially related to the topic that we'll discuss in our next episode. The principle of insular gigantism also applies to several unique species of plants on the island. Certain types of succulents and ferns, of which mainland varieties typically grow no larger than a few feet tall, have evolved to reach soaring heights that can make them appear more like trees than their mainland counterparts. Oddly enough, while insular evolution can lead to gigantism in species with otherwise small stature, species that are introduced to the island with pre-existing large size can actually experience the opposite pressure. Typically, these large-statured species evolve these traits to either avoid existing large predators, to outcompete other large species in terms of territory, or, in the case of plants, to keep leaves out of animals' reach or to exceed the height of other plants that might compete for sunlight. However, when these large species are introduced to an isolated environment without these factors that can keep their size advantageous, these traits are no longer selected for in future generations. So basically, on islands, small species evolve to get larger, and large species evolve to get smaller. In Madagascar, the most interesting example of this is the hippopotamus population, which once existed on the island. The Malagasy hippos gradually evolved to be significantly smaller in stature than their mainland cousins. The same, of course, apply to trees. with Malagasy baobab trees being typically a little bit shorter than their mainland equivalents. In our discussion on the geography and ecology of Madagascar, the term unique has become an omnipresent motif. In fact, when examining any element of Madagascar's geography or ecology, it's actually quite challenging to find things that do conform to the standards set out by the rest of the world. I mean, in most places, sandy deserts don't feature forests, but in Madagascar, they do. In most places, birds don't grow to the height of a moving truck, but in Madagascar, they do. When studying Madagascar, scholars have to toss out every assumption that they have about how the world innately and essentially is, because, well, in a sense, Madagascar is its own world. This perplexing island will consistently find a way to defy your expectations and be, well, unique. And when examining the island's human history, the island will not stop insisting on making us question everything we think are flawless and essential notions of our reality. In most places, history doesn't begin with a battle between semi-monstrous gnomes, travelers from thousands of miles away, and the confluence of cultures from around an entire oceanic coastline. But in Madagascar, it does. Join us for the next episode of the History of Africa podcast in 2 weeks, as we attempt to make sense of the complex and often contradictory narratives surrounding the arrival of human beings on Madagascar. Thank you for listening to the History of Africa podcast. If you like the show and the free education we provide, then we would love it if you could support the show. You can do this through supporting us monetarily at patreon.com/historyofafrica, providing the show with a rating or review on whichever platform you listen on, or sharing the show with anyone who you think might be interested in learning more about African history. This episode is brought to you by our supporters on Patreon, including Naomi Kanakia, Ayofagbamie, Morgan Blackmore, Sarah Mpenza, Tobias Tungland, Dimitri, Emmanuel Zaudi, Alexander Travis, BB Milliam, Conrad Schwenke, Travis Bell, Johnny Knowles, Godfrey Sabalabier, Diz RH, Evan Edwards, Pascal Onwakocha, Joe Maxwell, Nkechi Nobodike, Sheun Olorontimain, Kwajo Amankwa, Douglas Harder, Craig Bolton, and Samuel Badu, among others. Thank you all for supporting the show. It really, really, really means a lot.